Hi viewers, welcome to LMS Solution. Today we are going to see about sliding mode controller based P&O MPPT algorithm for solar PV system. This is the model used for testing the sliding mode controller based P&O MPPT algorithm for solar PV systems. This model consists of 250 watts PV panel. The open circuit voltage of the PV panel is 37.3 volt. The voltage at maximum power point is 30.7 volt. The short circuit current is 8.66 amps and current at maximum 4 point is 8.15 amps. Here you can see the IV and PV characteristics of this panel 250 watts PV panel. For different irradiation condition, the peak point will be going to be vary. For example, consider for 1000 watts per meter square, the peak power is around 250.2. For 800 watts per meter square, the peak power is 199.9 watts. For 600 watts per meter square, the peak power is 149.6. For 400 watts per meter square, the peak power is 98.97 watts. Depends upon the irradiation level, the peak point is going to be vary. So this point going to be extracted by means of MPPT algorithm. How that sliding mode controller based P&O MPPT algorithm, say extract the maximum power from the B panel. You will see the details. And then this is load, variable load is connected to the solar PV system via boost converter. We need to design the boost converter value L and C based upon the PV power. PV power is 250 watts. Under a standard test condition, the voltage across the PV panel is 30.7 volt. And then the voltage here we are going to fix is around 50 volt, 50 to 60 volt. For example, I'm going to consider 60 volt. Based upon this value, 250 watts, the input voltage and then output voltage, we have to design this L and C value based upon these values. Power of the PV panel input voltage and the output voltage, and then inductor ripple current percentage, capacitor voltage equal percentage. Based upon these things, we have to design this L and C. Next, we are going to apply MPPT algorithm based upon a sliding mode controller based P&O MPPT. Here you have a P&O MPPT. Here P&O MPPT will be provide the reference voltage based upon the PV voltage and current. So you have to measure PV voltage and current. It going to be generate the reference voltage. So it is a P&O MPPT, standard MPPT. That means about this P&O already we explained in my channel. You can see my yearly video about the P&O MPPT. You will get the better idea. So next you can see here we are taking the reference voltage from the P&O MPPT and we are going to compare the actual PV voltage. Here you are getting the error voltage. This error voltage and the rate of change of error voltage is going to be processed via sliding mode controller. The output of sliding mode controller is going to be processed via hysteresis controller. This hysteresis controller will be generate the pulse for this HBT in order to extract the maximum power from the PV panel. So this is a control logic of sliding mode control based P&O MPPT algorithm. Here we are combining the P&O method with the sliding mode control concept. That's why it is known as sliding mode controller based P&O MPPT algorithm. Here we are going to test the model with the two operating condition. One is change in irradiation condition with the constant load. So I'm going to operate this model with the constant load. I'm going to vary the irradiation for every 0.2 seconds. So every 0.2 seconds I'm going to vary the irradiation is 1000 watts per meter square and then 800, 600, 400. And then I'm going to check the power from the PV voltage and current and then power of the load voltage and current of the load. We are going to discuss. Now I'm going to simulate this model. Here every 0.2 second irradiation will vary from 1800 and 600 and then you have to check the results. Here you can see that for 1000 watts per meter square the maximum power is around 250 watts. For 800 the maximum power is around 200 watts and then for 600 the maximum power around 150 watts. This is PV voltage and then load voltage and then this is PV current and then this is load current. This is PV power and this is load power for a change in irradiation condition. So next I'm going to test the model with the change in load condition. For that I'm going to make the irradiation is constant and then I'm going to change the load for every 0.3 seconds. First step, this load will be added in the system. After 0.3 seconds, this load going to be added in the system. So we will discuss the results. So I'm going to simulate the model. After 0.3 seconds, load going to be added in the system. Here you can see that when load added into the system, you can see the load current change from here 2.8 times to nearly 3.5 amps because of change in load condition. you can see that the PV power is maintained at the maximum power point. That means you are operating the panel at the 1000 watts per meter square. Panel will be extract the 250 watts in all time. And also you can see that this is a variation of PV voltage and the load voltage. This is variation of PV current and the load current for a change in load condition. So this is the working of a sliding mode controller based P&O MPPT algorithm for solar PV systems. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you. Thank you so much. Bye bye.